Hello everyone. In this session of CCNA series, I will show you how to implement single area OSPF version 2. Enabling OSPF version 2 is very simple and requires only a few configuration commands. All you need to do is enable OSPF on each interface you intend to use in the network. And there are two ways you can enable OSPF on your network. One is traditional OSPF configuration using network command, and the second is an alternative configuration option called OSPF interface mode, in contrast with the traditional OSPF configuration. Let's take a simple scenario where I have three routers with R1 connected with point-to-point connection with R2 and R2 connected to R3. So subnet assigned between R1 and R2 is 172.16.1.0/24 with .1 assigned on R1 and .2 assigned on R2 interface. And similarly 172.16.2.0/24 between R2 and R3. So the OSPF configuration begins with, let me hop on to the router 1 and show you how to enable the OSPF. So in the global configuration mode, the OSPF configuration begins with router OSPF process ID global command. So router OSPF process ID is, I will select any value between 1 to 65535. So this puts you in the OSPF configuration mode. Okay, the process ID number just needs to be unique on the local router. It does not have to match on other router with which you will form a neighbor. And it can be any integer between 1 to 65535 as I said. And I will select the process ID as 1. So inside the OSPF process, you need to advertise your interfaces. And you can advertise the interfaces using network command. Okay, this command tells the router to find its local interfaces that matches the first two parameters in the network command. And the key to understanding the traditional OSPF configuration is to understand the OSPF network command. Okay, the command includes the network ID. For the R1, we have network ID as 172.16.1.0, and the second parameters you need to add is the wildcard mask. I will explain you how the wildcard mask is calculated, but for this network, it will be 0.0.0.255, and then you need to define the area ID. Since we are using single area OSPF, we will use area 0. So the network command is used, as I said, in the OSPF routing configuration to specify which interfaces should participate in the OSPF routing. So since we have only one network on R1, so we will add that network. Okay, so the network command along with the associated wildcard mask is used to specify which interface IP ranges should participate in the OSPF routing. So the wildcard mask determines which bit in the IP address are considered significant when matching interfaces to the network command. So just like a wildcard subnet mask, wildcard mask is a 32-bit long. The OSPF network command compares the first parameters, that is first two parameters in the command, to each interface IP address on the local router trying to find a match. Rather than comparing the entire number in the network command to the entire IPv4 address on the interface, the router compares a subset of the octet based on the wildcard mask. Okay, so the wildcard mask is like nothing but a reverse subnet mask if you make it simple. So when I say reverse a subnet mask, I mean that the binary ones and zeros of the wildcard mask are flipped compared to the subnet mask. So a subnet mask of 255.255.255.0 is same as the wildcard mask of 0.0.0.255. So if I convert that into binaries 1 and zeros, if you see, the wildcard mask is exactly the opposite of subnet mask. So 255, if we convert into binary, that is 8 times 1, and if you convert the same into wildcard mask, it will be all zeros. So a 0 in the wildcard mask indicates that the corresponding bit in the network address must match exactly. For example, 172. In the wildcard mask, it should match exactly. And a 1 in the wildcard mask indicate that the corresponding bit is a wildcard and can match any value. For example, in our network command where we have 255, it can match values from 0 to 255. And if you see the binary value, it flipped from zeros to 1. So a network of 172.16.1.100, for example, the wildcard mask will be 0.0.0. So let's go ahead and enable on each router and see what the wildcard mask and what type of wildcard mask will we use. For example, a network of 172.16.1.0 on R1, we can advertise it as 172.16.1.0 and 0.0.0.255 area 0. So let's go ahead and configure the same on router as we have done earlier. So we'll use this command, and we'll use another method, that is, for example, I can also advertise 172.16.1.2, that is the IP address of router 2 pointing to R1 as uh, like this 172.16.1.2, and the wildcard mask highlighted in purple will be 0.0.0 and area 0. So let me hop onto the router R2 and then advertise this interface, network 172.16.1.2. So my wildcard mask here will be, since I want to advertise only this interface using this command, it will be area 0. Okay, the neighbor already came up, as you can see from the log message. I will show you the show commands in the later part of this session, but I will show you how to enable OSPF using different wildcard mask. Now the next one, what I will do is I will use a range to enable this. Okay, so if I want to enable multiple subnets in one command, so I can use this network command 172.16. Sorry, there's a typo. It should be 172.16.0.0, and the wildcard mask here, if you see, is 0.0.255.255. So whatever address in the third octet, it will match everything. Like for example, from 1 to 255, it will match everything. So let's hop on to the router R2 and enable it. Okay, so I will enable 172.16.0.0, and the wildcard mask will be 0.0.255.255 area 0. Okay, so the OSPF neighbor with R3 will come up only when I have configuration on R3. So we will configure R3 with another special command, okay, which is, for example, if you want to enable all the interfaces in one command, this is the command, network 0.0.0.0, and the wildcard mask will match everything. That is 255.255.255.255. So it will match all the addresses. So let's go and configure this on R3. Router OSPF 1, and the network command will be 0.0 area 0. So this should bring up the OSPF neighborship with router 2. As you can see from the log, the neighbor is up. So now the next topic which I'm going to discuss is a very important topic. As you know, we discussed earlier, to add OSPF learn routes to the IP routing table, OSPF router uses three-step process. It creates the neighbor relationship, updates the LSDB, and runs the SPF algorithm on this LSDB to find the best route to add in the routing table. So there are three different commands to verify this process, or you can say, for example, to check the OSPF neighborship, I have show IP OSPF neighbor command, and to check the LSDB, I have show IP OSPF database command, and to check the route, I have show IP route command. So let's go ahead and check the neighbor relationship by using the show command. So the command to check the neighbor relationship is show IP OSPF neighbor. This command will give you the detailed information about your neighbor. For example, on R3, if you see, I have neighbor ID. So this will tell you what is the neighbor ID and the state of the neighbor, which is full, and the address of the neighbor to which you have formed the neighborship, that is 172.16.2.1, and the interface through which you have formed a neighbor, that is gig 0/0/0 on the R3 towards R2. So similarly, if you go on to R2, it will also show two neighbors because it is connected with two routers. Okay, so here, as I said earlier, it will show the neighbor ID of R1 and R2. It will show the state of both the neighbors. Then it will also show the address of the neighbor, which I mean the interface IP address of that to which you have formed the neighbors relationship and the interfaces. Okay, so to verify the OSPF database, I would use the command show IP OSPF database. This will display the database details. Okay, the output lists different types of LSAs. As you can see, router link state LSA and network link state LSA is there with all the details available. And to verify the routing table, I would use show IP route command. Since I have a directly connected neighbor, let me show you on R1 show IP route. This will show all the OSPF learned routes. Okay, so in this case, if you see router has received connected subnets, I mean this router has connected subnet as well as OSPF learned routes. The connected subnet, as I said, are shown with code C, and the OSPF, if you see the routes which I have learned, displays with L. Sorry, O. L is local. So the subnet 172.16.2.0, which is assigned between R2 and R3, is shown here as OSPF route. It lists the subnet ID. See, if you see, it lists the subnet ID and mask, which identifies the subnet. It also lists two another numbers in the bracket. Okay, the first number is the OSPF administrative distance, okay, which is by default 110, and the second number is the metric value. Okay, this lists the metric value. Along with that, it will also list the forwarding instruction. It has learned it via 172.16.1.2, that is the IP address of the R2 which is connected to R1, and through which interface. So my interface is 0/0/0 to which R2 is connected. So once you have completed all the configuration, and if something is not working, then you can troubleshoot to check if your configuration is correct. And that command is, for example, either you can use show running config and begin router. So it will show the OSPF configuration, or you can issue a show IP protocol command and see if it will list all the detail, like which interfaces are, which gateways are connected and which network you are advertising. It will also include another important thing, that is router ID. Let me tell you how this router selects the router ID. Okay, OSPF enabled router must have a router ID for proper operation. By default, router will choose an interface IP address to use the router ID. And to choose a router ID, Cisco router has a certain process. For example, if you have a router ID command configured, then that value will be considered. As you can see from the configuration, I have a loop back here. That's why it is selecting this. Or if I go to R2 show IP protocol, it will list the router IP, interface address. Okay, actually there are three election method which OSPF chooses. First one is if the router ID is configured, or the second one is the highest loopback address configured, or the third is the router will choose the highest IP address from all the interfaces available. So if I do show IP interface command, it will select the highest IP address. So here it has selected this address, and if I go to router 1, it has selected loop back because that is the second option. The third option is the highest IP address. So we can tell a router to select the router ID by configuring the router ID command. And for that, what I will do is I will tell the router R2 to select my lower IP address as the router ID, so that I can show you how the router ID command influences. So I will select another 1.2. Okay, and to make this effect, you need to clear the IP OSPF process. Okay, then I will change this, and then now you can see my OSPF router is having a new router ID. So it immediately changed after clearing the OSPF process. Before, if you see, the router ID was 2.1. That's it for this session. I hope this was informative for you. Thank you for watching.